Everyone, and welcome to my channel. Today we're talking about stealing NTLM V2 hashes from SMB shares. But before we dive into the practical aspect of things, I want us to quickly understand what NTLM is. Now, when we are talking about NTLM stands for NT-LAN Manager, and it was developed by Microsoft for network authentication on Windows system. It's mostly used to authenticate users and provide access to resources on a network. And it relies on a challenge response mechanism to authenticate users. It involves the exchange of challenge and response message between the client and the server, meaning the client and the server has to have some kind of communication before authentication is given to the particular user. And now we have different types of NTLM. We have NTLM v1 and NTLM v2. NTLM v1 is the older version of the older protocol version of NTLM, and it is pretty weak. I mean, very weak and short. It's vulnerable to some certain attacks, including pass the hash, like I've listed here. We also have NTLM v2, which is improved version with stronger security features, and it's also resistant to some of the vulnerability present in NTLM v1. Literally, we all know what SMB shares are. We all know what SMB is. So going into the practical aspect today, we'll be using a tool called NTLM Theft. Now, NTLM Theft was developed by Wolf, which you can see here on GitHub, and I'm going to put the link in the description. With this tool, we can successfully poison the SMB share, and then we'll just start up responder, get the hash. Responder to literally listing through our payload. It's gonna listen through our payload, then start up responder, and then we'll grab the hash. Now, there are some certain conditions that have to be met before this attack will work. First of all, you have to have SMB port running on the target, and SMB just stands for server message blocks, that is used to transfer files across devices like printers, users, servers. Now, once we have the port open, which is either 445 or 139, which is the older protocol, 445, which is more updated protocol of SMB. Once we have these two, we also have to make sure we can actually put files in the target shares. What does this mean? You can actually put files in the target share. You can run put command with SMB, and then you'll be able to put files in the target share. Now, before we get started, we need to install NTLM Theft first, and we can do this by running this command right here. So I'm just going to copy this and see if I have that installed already. I'm going to spawn my terminal, make this a little bit big, paste it in, and then click enter. Now this should install the XWriter library for Python, because we are going to be needing this. Now you can see this requirement already satisfied, XLS writer in this present location. So once we have that installed, we can go ahead and then clone this directory, right? So you just need to come over here and then copy this, and once this is copied to your keyboard, head over back to your terminal, and then just run git and clone, and then just paste that in like that. So once that is pasted in, it will start the process of installing the NTLM Theft, which is what we are going to use to steal the NTLM hashes of our target. Now, I'm just going to cd to NTLM Theft, right? About NTLM Theft, and if I run ls, you can see I literally have the files here. So now I do have NTLM Theft.py, which is what we are going to be needing. You just edit NTLM.py to see how the script works, right? So this is literally the script. This is literally the script, and we can see open files. You can see the files they support that we can actually put into the target system, and got everything here. dockers file with frameworks, and you can see what each file will generate. Well, we are going to show all of this in the practical aspect. So one more thing to do is to download responder, like responder.py. Let me just do responder.py, see if I have that right. Yeah, no, responder, which is this. Responder, yeah, dash help. And yeah, I do have responder installed. So if you run responder dash help, and you can see this right here, you also do have responder installed. Now I think the responder config is stored under let me just edit that a little bit, mousepad / etc / responder, right? Yeah, responder. Yeah, that's true. That responder. Yeah, responder. That's not gonna mousepad. I have to actually cd to that directory. So cd there, and then I'll just run ls, and we have responder.conf there. So I can go ahead and just sudo out responder.conf, right? Sudo git responder.conf. So okay, that should be after that. I'm just going to type in my password, and then I have that. So now because I don't actually have any labs out there, to practice this, I'm just going to be using a CTA platform called TryAcme, and just want you to stay with me. So here's what I've done so far. I've spawned up my TryAcme, this room from TryAcme called Reset. It's an ad box. If you want to try it out, I can drop the walkthrough down below in the link. And also I'm gonna head to launch Tmox, which is a much more interactive shell, because it gives me the avenue to be able to divide my screen and make my screen much more neat and all of that. So I'm just gonna collect this. I've also spawned up TryAcme VPN, which actually puts me in TryAcme network, right? So now if I go ahead and pinch the IP address, which is our target IP address, you can see it's up right now. So the next thing I can actually do is to actually perform an nmap scan to see if our target truly has SMB opened. So I know SMB port is usually 139 or 445. So I'm just going to do that, and then SV. I'm not going to run a script scan because that is not the purpose of this. And I'm just going to add dash T4 just to make it much more faster. And I'm going to add verbosity, right? So I'm just going to enter here, and let's just see if it tells me these two ports are open. If it is really up or blocking our French bros. Okay, so we need to add -pn also. So it's gonna actually treat the target as if it's literally up. Yeah, you can see discovered open port 139 and discovered port open port 445 on our target. So we truly know our target has SMB open. So now we can go ahead and perform our SMB enumeration by just doing something like SMB clients. You can just do SMB client, then -l, and you're gonna add 4 like this, like 4 backslashes, and then just add 2. So now what this is going to do, it's actually just a delta. You can go ahead and hit enter here. What this is going to do is actually going to list all available shares on our target. So you can see we have available shares here. These are all available shares in which we have. Yeah, I think so. Yeah, if you do SMB client shell, and then you add this here, you can actually see we get this data share, which is what I'm going to be attacking today. That's where I'm going to put in my malicious payload. So now I'm just going to do SMB client again, and I'm going to remove this help this time, right? Literally I just want to connect to this share right now. That's what I want to do. So I'm just going to put data here, and I'm just going to hit enter, and now you can see I'm actually connected to the share. You can run the help command to see what you have, all the available commands you have on SMB client, all info that's typically followed by file. So if I run dir now, if I run dir, you can see that we have a share called onboard, right? Just run that dir. So we have a share called onboarding and it's a directory, right? It's a directory here. So we can go ahead and see to onboard. Now I'm in onboarding already. I can run dir again, and you can see we have quite some files here. Now you can go ahead and download these files, see what they are. If I was actually solving the boss, I will actually download the files, see what they are here. But one thing we notice here is that if we wait a little bit, the text inside this directory literally changes. Like the files inside this directory literally changes, meaning that there's probably a user performing an operation or performing a task in this present share. Now once we can inject our own malicious payload, then the target will be able to execute it automatically, maybe by mistake, and then from there, if the target just tries to click on it or try to open it, then from there we literally have the target NTLM v2 hash in our responder output. So yeah, let's go ahead and do some kind of stuff. Let me run dir again, see if anything changes. Yeah, you can see here that we have 4CE and here we have 55. That's what I just wanted to show you. So if I go back to my nmap scan here, you can see Windows NetBIOS SNN, which literally means we got SMB open already. So now I'll try to put a file here. Let me just try to touch a file called whatever.txt, right? Let's just call it whatever.txt. Now you have to place it inside the same directory where you spawned this SMB share, right? So I think that's the same directory where I spawned the SMB share. So now if I do put whatever.txt, now you can see putting file whatever.txt as onboarding, which means successful. Now if I run dir, you should see whatever.txt here. Now if I try to see the dot slash, that's one step backward, right? And then I try to put whatever.txt here, I'm gonna get an access denied, meaning okay, I can actually put files here also. That's great. But if you get an access denied, then probably this attack is not possible. You actually need to find a way to put a file in that target share, right? So yeah, so once I have this, I have to click on it's gonna work. But once I have this now, we can go ahead and craft our malicious payload. Before we craft our malicious payload, we need to have your attacker's IP address. So I already know the interface for my track VPN interface with TUN0, so you can see the IP here. So you can copy the IP, and I'm going to click Ctrl X, come back here, and now let's just go back to the article, see what we have. So yeah, you can see the format in which we were given here, right? Python 3 NTLM text.py-g all followed by test, which is great. So let's just do that here. We're just going to type in Python 3, right? Python 3 NTLM text.py, what else? -g all and -s. So we're going to do -g all -s. Let's see what we have. -s followed by the IP address. You just paste in your attacker's IP address there. -f test. I think that can just be anything. It could be anything you literally want it to be. Does not really matter. So yeah, once we have that, once we have all these meds, you can just go ahead and hit enter, and you can see generation complete. So now if I hit LSA, I'm going to see a folder called test. Yeah, so I'm just going to go ahead and cd to that folder called test, right? I'm going to clear this and then ls, and you can see we have all of these files, right? So yeah, so the file we're going to be putting inside this guy here is this test.lnk. We're going to be putting test.lnk into this guy. So I'm just going to come here and I'm just going to hit Ctrl D to go up from there. I'm going to run ls and I'm going to cd test, right? So now I'm going to run that SMB command, which I ran again, enter. That's just anonymous. I did not explain that, sorry about that. Well, anonymous connection to SMB clients should actually be disabled. That's another security vulnerability, because if we are able to actually put if we are able to actually connect to the SMB share anonymously, that's a vulnerability. One, if we can put files in the SMB share, that's another vulnerability. So yeah, let's just go ahead and set up a Python. Oh no, we don't need to do that yet. So what I'm just going to do is go ahead and start up responder probably here. Let me just start it up here so you can literally see what's going on after your stuff. So you're going to do sudo responder, right? Sudo just responder this. In case you don't have responder, I think you do sudo apt install responder. I think that should literally work, right? Or responder, yeah, that should work. So yeah, once you have responder installed, you can just go ahead and run sudo responder just like that -i, and then just specify the interface, right? Yeah, so now once you have this, or you can see listening for all events. Now the only thing I want to clarify is this: you should have this you should have SMB, which is the servers. You should have SMB probably on. You should have SMB set to on, because we are actually dealing with the SMB protocol here. So this should be set to on, but I think it's actually set to on defaultly, so there's no need of actually doing anything there. So now I'm just going to come over here and I'm going to go ahead and put test. Okay, let me just cd it to the onboarding directory, since that is where the automation is going on, right? So now I'm just going to run dir out here, and then I'm just going to do put then test .lnk. Yeah, so you can see there's a lnk as we put here now. So now you see what happens there. Immediately we get a user hash, and the user is called automate, right? So yeah, we have actually put in a poisonous file into this server, and then once the user executes that poisonous or malicious payload, it literally gives us back the user's NTLM hash. So it's just basically like a man in the middle attack, but nothing man in the middle attack. So what we can do now is, because this is actually an NTLM v2 hash, we cannot actually use it for attacks like pass the hash, because it's quite secured. It has additional security features. So what you're going to do is copy this NTLM hash. This is the name, this is the host name, and this is the NTLM hash. So let me just open up another. Let's just use this guy here. So go ahead and save it into a file, probably whatever you want to save it into, and I've saved it to this file right here, right? So I have the NTLM hash saved here, which is awesome. So we're going to use Ctrl S here, and then what we can literally do now is to try to crack the hash. So we could use John the Ripper, just to John hash.txt, then just to user share. If you use Kali Linux, I think this is the default word list for this is the default word list part for Rocky, for Rocky.txt. Oh, made a mistake there. So you need to add sorry about that. Let's turn this off. Rocky, yeah. So we need to add -- word list into this. Just add word list is equals to, and then you're good. So you can see that was pretty fast. So you can see here now we have the password, which is password 1, and we have the username, which is automate. So now we can go ahead and log in to this user using EvilWinRM or PSSZ or whatever you feel like you want to use. What I feel like using EvilWinRM. So let me just do EvilWinRM -i. I think yeah, -i. So we're going to do thm.conf, I remember, right? Yeah, and then -u, probably I'm just going to do automate, and -p, I'm going to do password. So let me just copy this and hit enter. So let's see if this works and if we are able to log in. Let me just do something like this. Instead of using thm.conf, I'm just going to use a direct IP address, right? So let me just copy this IP address and see. just gonna paste that IP address there. Let's see if it works now. Yeah, boom, it works. So if I run host name, you can see host a stack, and if I run who am I, PHM automate, you can see the user here. So now this is actually a security this is actually a vulnerability which I still see out there. I mean, it's still out there. I mean, it's actually a feature, I mean, a misconfiguration in the essence that first of all, we have anonymous access to the SMB share. Secondly, we can put files. I mean, these security features, these features can actually be disabled in SMB. So we can put files, we can log in via anonymous, means we have anonymous access, we can put files, and once any user can actually click or make any interaction with files we actually put in that SMB share, boom, we get that user hash. So these two things should be taken note of. Make sure to disable anonymous access to SMB shares, and also make sure to avoid the put functions, and I mean to turn off the put function in SMB shares. Thank you for watching, and please like, share, and subscribe. Thanks.